All right, well, welcome everybody to this month's meeting of GlugNet. Tonight we are pleased to welcome Steve Smith, also known as Ardalis, and he will be discussing data access patterns and their evolution with us tonight. A little bit about us. We are the Greater Lansing user group for .NET developers, based out of Okemos, Michigan, as pictured here in the map. Our meetings are held every month on the third Thursday, and they are all free and open to the public. The best way to find out about us is to go to meetup.com/glugnet, where you'll see all of our past events as well as the things we have scheduled for the future. For future meetups, we are looking to incorporate some lightning talks. So if you have something you want to present, please reach out to Joe Punk or myself, and we will try to schedule you in another meeting. At this point, we would like to thank our sponsors for the evening, NIS Technologies, who is providing us this go-to-meeting session, the .NET Foundation, who pays the bills for the organization, and TechSmith, who is our normal physical hosting site. Our meetups are recorded and posted to YouTube by our own Sam Nasser. You can either use the QR code on the screen there, or you can go to youtube.com/@SamNasserMVP to find past meetups. During tonight's presentation, if you have questions, feel free to either submit those through the chat feature or unmute yourself and ask at any point. Or if our presenter has any questions that he would like us to answer, feel free to unmute. Otherwise, we ask that you just please remain muted so everybody can enjoy the presentation. At the conclusion of tonight's presentation, there will be a feedback survey. All feedback collected is anonymous and summarized for Steve to improve his presentations going forward. So I would very much appreciate if you would please fill that out at the end and give us your honest feedback. Good, bad, or indifferent, we want to know what you thought. Some other related meetups that you might be interested in, our friends at the Cleveland C# VB.NET user group, led by Sam Nasser, the Greater Lansing area for SQL Server. There is also a .NET study group that Sam leads. It's very good. And there's an in-person event based out of Southfield, Michigan, MI.NET. Used to be what was MI Gang. So if you are in the area, you may want to check that one out as well.
I keep forgetting they're back. Oh, sorry.
Yeah, they are. Brian Krasinski and another guy are running it. But they are, at this point, only in person. But still worth checking out if you're willing to make the trip there, Daniel. All right. Well, that's all I have. Let me stop sharing, and I will turn it over to Steve.
Cool. Thanks, Stephen. I must be the presenter. There we go. And do that and share that. And hopefully you all can see my screen. So thanks everybody for taking time out of your evening to come and talk about .NET and data access with me. My name is Steve Smith. Because there's a million Steve Smiths, I go by Ardalis online. So you'll find me on Twitter, GitHub, or wherever as Ardalis, or on ardalis.com for my blog. I work for NimblePros. I'm a co-founder, and we're a small consulting company. We do a lot of training and mentoring. Mostly we try and make your team better by teaching you different patterns or improving your code or processes or things like that. So if you think that your team could use some help, give us a call, or more likely send us an email, and we'll see if there's something that we can do together. Tonight, we're going to take a look at this idea of data access and different types of patterns that you can use to access data. The goal here is to kind of continuously evolve our approach based on the feedback that we get as we use it. You know, as we apply a certain pattern, as we use it on a larger application, you know, you experience different forms of feedback, different types of pain that you know, things that were fine when you had a small app become more difficult when it gets bigger. And we're going to sort of let you learn 20 years worth of industry experience in an hour by just kind of fast forwarding through the evolution of some of these patterns. And you'll be able to see, like, well, why do we use tools like Dapper these days? Where did that come from? You know, why didn't we just start with that? You know, why is that a third-party thing? Hopefully you'll have a better understanding of, you know, the low-level implementations that Microsoft had in the early .NET days, and how that led to kind of where we are today. So this is an example of a SQL table layout. You can see, you know, foreign keys and relationships between the tables. So, you know, we're going to talk a lot about this type of data. Most of your apps are typically going to need some access to data. It could be arranged in columns and tables and rows, like a typical SQL schema, or it could be that, you know, it's set up as a document store, usually in JSON or something else, maybe XML. Either way, we have to have our application set up so that it can access this data, so it can, you know, fetch the data that it needs and store updates or changes to the data. The vast majority of applications that I work with, the application doesn't necessarily need to concern itself too much with exactly how the data is stored. There are, of course, exceptions. There are features of different databases that you can take advantage of, and, you know, if you do put an abstraction in front of that, it can make it more difficult to leverage some of the unique capabilities of this or that data provider or data store. But for a lot of just general CRUD functionality, for a lot of even complex applications that have, you know, detailed analytics and other capabilities that they need to use from their data store, they still have a bunch of settings screens that are just CRUD, right? They still have a place where the user can update their profile that's just CRUD. And so there's generally a lot of simple, I say CRUD, meaning create, read, update, delete a record logic in even applications that do leverage, you know, larger capabilities of whatever data store they're using. Since I'm primarily a .NET developer, I've been doing stuff with .NET since before it, you know, version 1 shipped. I'm going to be focusing on .NET, pretty much C#, and we're going to look at, you know, how you can build these things using the .NET framework and features. But a lot of the abstractions and patterns I'm going to introduce apply regardless of what framework you're using. They'll generally work best in an object-oriented paradigm. So if you're using Java, it would work, you know, pretty much the same as it does in .NET for the most part. But if you're using a whole different stack, then it may not be quite as applicable. All right. I also have a bunch of Guardians of the Galaxy artwork in here because I recently gave this at Star Trek conference in Ohio, which was co-hosted with the premiere of the Guardians of the Galaxy show a few weeks ago. So I threw some of those in there to add some interest. So let's jump right into a demo. I'm not going to actually run the code because it's not really needed. I'll just show you the code in the slides. It goes quicker that way. But I do want to show you how we would just fetch some data using ADO.NET. And for all of the demos I'm going to show you, imagine the thing that's actually calling the data access code is an API endpoint. For example, you want to get a list of authors, or you want to get a list of authors with their courses, or you want to get a specific author. Is sort of the model that I'm using, where an author might be, you know, a Pluralsight author. I have a bunch of courses on Pluralsight, so that's where I got the idea for the demo. And so in this first piece of code right here, we're going to work directly with ADO.NET, which is in the system.data namespace in .NET, whether you're talking about old school, you know, original .NET framework or .NET Core, .NET 7. It's the same set of libraries. They've ported them forward, and they're pretty much completely backward compatible in .NET 7 from what you had in .NET 1, which is honestly pretty amazing that they were able to do that. But here we are 20 some years after .NET 1 shipped, and we're still able to write this type of code. Now, like I said, many developers maybe have never even written this type of code because they've always had a tool that sat on top of it. But let's look at this and let's consider you know, what all is happening here. So initially, I'm going to just create a collection of authors that's empty. That's going to be my author DTOs. That's not the same as the thing that's going to come back from the database necessarily. I have to open up a connection. So I'm using a relatively new C# feature here where I can add a using statement and it will close the using block automatically for me at the end of this function or this block. And so it's just got a semicolon at the end. Previously, you would have to say using, put it in parentheses, add a curly brace, and everything down below that would be nested in one, which got to be annoying quickly because there were so many different using statements you needed to work with ADO.NET. Then I have my query. I'm just going to say select star, so every column from authors. I'm going to create a SQL command, pass it in the SQL query and the connection that we're using. I have to open the connection explicitly before I can actually start to use it. And under the covers, that might use connection pulling, or it might actually open the connection to the database right at that moment. That's abstracted away from us, so we don't have to worry about that so much. I'm going to use a SQL data reader, which is this reader type right here. And I open that up by calling on the command, I tell it to execute this reader. And so what that's going to do is open a connection to the database. Technically, the connection's already open. Send a command to the database that is this SQL right here. And then while that command is open, it'll be listening for a result to come back. And so you can say if the reader still has more rows to read, we're going to loop over it, and we're going to take the next row here and say get in 32. This 0, this magic number here, it means that's the index of the column that I'm reading. So give me the 0th column, the first column, and make that the ID. Give me the second column and make that the name. And then eventually I'm going to add that to my DTO, which we instantiated right here. So I'm going to add it to my collection of DTOs. All right, so this works better in person. And I know we have a small group, but if you don't mind, I want to ask a quick question here. Looking closely at this code, do you see anything wrong with it? And I'll give you a hint. I wouldn't ask if there weren't some things here that you might want to point out. So VJ says close the connection. Yep, go ahead, Daniel.
Oh, I was about to say close the connection, but I forgot you're using. So
that's right. So yeah, so close connection is an obvious one that you would expect to see here. However, the connection is disposable. So I'm using this using statement, and it will close the connection for me at the end of the using statement. So that one, it's weird to have an open with no close. I agree, but the best practice is to do it this way. So it does kind of make it confusing, which is one of the things that's wrong with writing this type of code, is that it ends up being confusing like that. What else?
well,
You're on the right track.
I'm not sure if it's considered wrong, but referencing them by index, you'd have to rely on them coming back in a certain order. And if that order ever changed, you just hosed your method.
That's right. Yeah, so that's not necessarily a bug in this code as long as nothing changes. But because I'm saying like the name column will always be 1, and especially because I'm saying select star, I'm not even specifying the order of the columns here. I'm just relying on that convention not changing, that no one's going to reorder the schema and add a column in between 0 and 1 or even first, which would break these mappings here. So yeah, so that's definitely a code smell, if nothing else. Not necessarily a bug here, but definitely a downside to this approach. All right, so another one that you might say is there's no closing for the reader, because the reader is also something that needs to be closed. Turns out that follows the same pattern though. So because I'm using a using statement, it's okay. I don't really need that. But it is a little confusing because it does have a close method, and I'm not calling it. And so someone in a code review might call that out and expect it to have to be there. So again, it's a confusing convention, the way you're supposed to work with this API. The one that actually is wrong and that we should add, although the consequences are minimal, is the fact that command, the SQL command, is also idisposable. And so to do this right, I should really have a using in front of this var command line as well. Most people forget about that, and honestly, if you don't have it, it almost never has any consequences on your code. But because it is idisposable, by best practice in C#, you should always put that in a using block so that you can call dispose on it properly. All right, so enough with that. Let's look at a slightly more complicated version of this code. It's running essentially the same type of logic, but now I'm doing a join, and I'm saying give me an author along with all of their courses. And just to give you an idea of the relationship here, there's a many-to-many relationship between authors and courses, because you might have one author that's published several courses. I have, like, I don't know, 15 or 20 courses, I forget. And so you have that, one author can have many courses, but you can also have a course with more than one author. There's not very many of them out there, but Julie Lerman and I did a course on domain-driven design. Actually did it twice because we updated it for .NET Core. And so there are courses that have two authors. And then for a given author course combination, you get a certain royalty as part of your relationship with Pluralsight for that course. So that's how you get paid. And so on that many-to-many relationship, there is also this royalty. So if you look at this SQL query, you can kind of see how I'm joining between the authors table, the course author join table in between, and then the courses table to fetch the course title in addition to these other columns, right? And then I've got a SQL command. Notice I've got a using statement here this time because I'm doing it right. I'm adding a parameter here for @authorID. One thing you want to be careful you don't do is build these strings with concatenation. That'll obviously have security problems. It'll make you susceptible to a SQL injection attack if that code is coming from user input. I'm going to execute the reader down here just like we did before. And then it's just a slightly more complex mapping here to build out this DTO of authors who have courses, and those courses are course DTOs. All right. And we could probably run this code here real quick just to show what the data looks like on the back end. So here's my demo solution. You can find it. Of course, it doesn't build. Why would it build? You can find it on my GitHub, and you don't know a definition for list. My author. You should have a definition for list. Oh, list async. That's right. I changed that at some point. There we go. I don't know why that was not building, but hey, now it works. All right. So anyway, .NET Data Access Tour is where this is at. I'll show you a link here in a second. Let me see if I can grab this window. There you go. So here is github.com /Dallas .NET Data Access Tour. That's the URL you want right here. I don't know if the chat gets persisted anywhere, but here it is in the chat. This will have the latest updates if I ever make any. In here, if you want to see kind of what this looks like, we can open up Swagger, and we're going to see ADO.NET SQL. That's the first thing we're doing here. If I want to get an author with their courses, we can do, this will be all of them. So this will just be authors. And, oh, you know what? I need to do something before this will work. I'll show you that demo in a second. Let me jump back to code. All right, so there is one step I need to run in a command line. So when I take a quick sec to take a drink of water, I'll run that, and then I'll show you what the code looks like. But this is basically the ADO.NET code. So the thing here that we want to talk about next is what are some of the characteristics of this code? What are some ways that we could assess how we like this way of writing code? And so there's a whole bunch of different ways you can assess software or code or architecture. And I've picked 5 that I want to describe here. And those are the readability, security, performance, testability, and maintainability. And for any one of these, we can kind of grade one of our approaches based on how it scores across these different areas. They should be pretty self-explanatory. Readability is like how easy is it for a developer to see what it's doing and understand it really quickly at a glance. Security is obviously how secure it is. Performance is how fast it is. Testability is how easy it is to test that code. And just as importantly, if not more, the code that's calling it. The thing about data access code is it often makes it so that the code that has that code in it becomes really difficult to test. And then maintainability is related to testability in many cases and readability, but it has to do with other things like separation of concerns or duplication, things like that can make it more difficult to maintain. So if we kind of put together a report card for this pure ADO.NET approach, the biggest concern I have with it from a readability standpoint is that there is just a lot of code. And when you look at a lot of code like that, you're going to copy paste it all over the place, anywhere in your app where you need to make some query. And because it's being copy pasted all over, and it's like 10 or 15 or 20 lines of code everywhere you want to use it, it means that there's a lot of code to look at, and it's a lot of possibilities that you could have, a small typo or an off by one error, or forget a using statement or something like that, and easily miss it because you're so used to seeing all that boilerplate code, you don't necessarily look at it that closely every time you see it in a method. From a security standpoint, the biggest issue with it is the magic strings that are in the code. You just have to be super careful that you don't accidentally ever work with those strings in a way that allows user input to be directly attached to them, which will give you a SQL injection attack, which is still one of the biggest security holes in web applications. From a performance standpoint, I'm going to give it 5 stars because it is as fast as we can get. It's bare metal, just talking directly to the database and getting the data back as fast as we can. So anything else we stack on top of this is probably going to slow it down, but hopefully it gives us some other benefits. Testability wise, this code is really poor. It's very hard to test any logic that has this code in it because it only works if there's a database for it to talk to. And so you have to have a real database involved in order to run the code that has this code in it. Otherwise, it'll throw an exception and say it couldn't find its database. And so that's a big problem. And maintainability, I'm giving it 2 stars because low testability and so much code. It's just a pain to keep up that much code. All right, so I'm a big fan of something I call pain-driven development. So as we look at each approach, we're going to try and identify the pain points and then see if we can fix those pain points. Now, it may not always be obvious where the pain points are if you just look at one little sample out of context, but imagine that you have hundreds of endpoints or hundreds of pages or forms or whatever in your application, and all of them have this code, and you're responsible for maintaining all of it. Right, that's where you can start to see where the pain would start to enter in. All right, so let's look at the next example, which is going to use ADO.NET, but we're going to use store procedures. So back in the early days of .NET, it was very common for applications to be required to perform all of their data access through store procedures because most companies had a big expensive database. They had a big expensive database administrator whose job was to take care of that database, and that DBA would not let you touch their database without them having a lot of control over that. They didn't trust these newfangled web developers to know what they were doing. And so they would handcraft bespoke stored procedure calls for anything you needed to do with that database. And so you would have to write code like this, where the main difference is that instead of having the actual query, the actual SQL inside of your C# code, you now have the name of the stored procedure inside your C# code. So in this case, it's list authors. Inside of list authors, it's literally the same thing that was there before. It just says select star from authors. Likewise, if you want to grab the author with all their courses, it would look like this. A big benefit of this is that you don't have as much logic inside of your code, but it's also a downside. Right now, your logic is spread between the database and the code. And so that makes it more maintainable in some ways, less maintainable in others. It does give it better security though, because it's more difficult to do a SQL injection attack into a stored procedure that's using parameters than if you're just building the query yourself ad hoc. So there's a small readability improvement here. You've got a named stored procedure and you don't have as much copy paste query code. Security is better, performance is still great. Testability isn't really changed, and maintainability is maybe slightly better because there might be fewer magic strings or smaller magic strings in the code. But this assumes that the database is well maintained, and that's an assumption that's not always true. So let's look at another way that we can shrink the code. So our biggest pain point with this code at the moment is that there's just so much of it. You've got a whole slide worth of code when all you're really trying to do is make a query and then map it to some C# objects when you're done. And so Dapper is a really nice micro ORM that provides you with this interface that acts as an extension method on top of a connection. And so you would just take a SQL connection, you go ahead and say that you're going to use Dapper on top of that and say con.query, like you see here in this first arrow, and tell it the type that you want it to map it to, and it does the rest, right? And so it figures out how to map that query into that DTO for you using conventions, or you can provide it with some information if you need to. And even for a more complicated join like this one, it can do the right thing. You can help it out. You can tell it query multiple, and then read, each single thing and read each DTO and add the courses. It's not quite smart enough to necessarily do it all in one flow every time, but with a little bit of knowledge of its API, it's pretty easy for you to do the same work. And now you can see that it's so much smaller that we're actually able to take those two big slides and just put them together here on one slide to show both of those examples. Okay, so let's look at a report card for Dapper then. Actually, sorry, let's look at store procedures with Dapper. So Dapper with store procedures looks just the same, right? Here's the queries inside SQL. Here's with store procedures, it just gets a little bit shorter. And nothing else really had to change here except that we told it the command type is store procedure. And then everything just works the way it did before. All right, so this is looking a lot better, right? The readability is easier, the footprint is smaller. I don't have to remember whether or not I'm closing a connection or closing a reader. I don't have all these magic numbers for how I'm mapping stuff. So it's more readable. Security is about the same as it was. Performance is excellent. Dapper's known for being a really high performing way to do data access. That's one of the main selling points that it has. The code is still really hard to test, right? Just because we've decided to introduce Dapper doesn't mean we're not tightly coupled to an actual database connection. Dapper sits on top of the database connection, so it's definitely still expecting that database to be there when it runs. And so testability is still horrible. But the maintainability is otherwise pretty good. So if you're okay with only running integration tests and not being able to write unit tests for your code that uses this, it's not terrible. So the maintainability is decent but not great, in my opinion. Okay, so a big pain point with any of these low-level SQL-based approaches is updates. You need to add a separate set expression to the update command for every property that you want to update. That's just how SQL works if you're working with a relational database and SQL Server, Oracle, whatever it might be. So if the user changed one field, you have to figure out which field did they change and then update your query so that you set that column's value to be the new value that they just changed it to. Now you don't have to do that. You could say, I'm just going to update all the columns, right? And so I can say update author, set every single column to the new value, and then pass it the current state of things. And even if most of them didn't change, you only update you update all of them. And so essentially you're updating things to be what they already were. Now the problem with that can be overwrites, right? If somebody else just did an update of say last name, and now you're saying, okay, I just did a query a minute ago, I've got the record here, and I'm going to update the I don't know, the address, right? The street address, right? So I send back an update of the street address, but somebody else just changed the name, and I say set everything to what I have, and what I have is out of date, right? Because my query that I got to get the data was a minute ago, and so I don't have that name update. And so when I update name to be what it is or what I think it is, I'm actually destroying an update that already occurred. Now there's various ways that you can prevent that. You can put in row version checks and things like that, and if you have a decent amount of time between when you query and when you update, you absolutely should consider doing row version checks. But it does present a common problem here where it's difficult for you as the application developer to figure out which things did or did not change, and then how you're going to create the most efficient query to perform that update appropriately. Okay, so the thing that we need is some kind of change tracking. And at that point, instead of using a micro ORM, we're going to want to use a full object relational mapper like Entity Framework or EF Core. And so let's take a look at what EF Core would look like if we introduce this. Now, again, we're following this pain-driven approach where the pain that we're feeling is now coming from the updates, and to a lesser extent, the fact that we still have all these magic strings of SQL inside of our code, whether it's full queries or individual store procedure names. The less red text that you have inside your code editor that is representing magic strings, generally the better. And one reason for that, let's come back here. Let's look at this red text. One reason for that is that if you make an update to your model and you say, you know what, name isn't really the right name for an author, let's call that full name, right? And so you go into the author.cs file and you change the class and you say, well, let's make name full name, and you hit F2 or Control Dot or whatever it is you use to do the rename refactoring. Visual Studio or VS Code or resharper, rider, whatever you're using, all those things support rename as a refactoring tool, where it will go find every instance of that in your code base and rename it. And suddenly author.name is author.fullname everywhere, except for here, because this is just a magic string. And so, you have not updated how it talks to the database. Now, on the plus side, this might not actually break anything, because your @name here that you're setting is probably being set to full name now at this point. And you didn't necessarily change the schema of the table, so it might still just work the way it did. But your schema no longer matches your object model, which to me is not great, right? In domain-driven design, you want to have what's called a ubiquitous language, where you use the same terminology for everything everywhere. And ideally, your C# classes should map to the tables or documents that are in your data store, and the properties on those classes should map to the rows or properties in the persistence layer as well. The less you have to translate between different models or different names of things, the better, the fewer bugs you're going to have. And so that's another downside to this approach with the magic strings, is that they are not going to get picked up by automatic refactoring tools. All right, so with that, let's look at EF Core. So here's those two queries with EF Core. For EF Core, I can say, go give me the dbcontext.authors, select it. This will do a projection into my DTO. Now, the cool thing about this approach is that I'm not providing it with the SQL. It's going to generate the query for me. And it's smart enough that it's going to generate the query based on this projection I'm doing. So in my example, author only has an ID and a name. It doesn't really have a whole lot else. It's got a courses property, but that's about it. In a real world scenario, author would probably have 20 different properties at least. That would include a bunch of more data about the author. And so if I only needed the ID and the name, then by doing this projection, my query isn't going to be select star, and it's not going to be select 1, 2, 3, 4, 5, 6, 7, 8, 9 through 20 properties. It's going to just be select ID comma name from author. So it's going to be a much more efficient query. It's only going to bring back the data that it needs. Same thing with this more complicated query here. By using include and then include, I'm telling it to go and do those joins and fetch the related entities that I need that are in different tables. And so it's going to go grab the courses and the course itself so that it can do this mapping. And once again, this projection here, this dot select, even though it's more complicated here, it's only going to fetch those columns that it needs. It can detect the ones that I'm referencing here inside this select statement, and it'll put it inside of the actual SQL select statement that it's going to write. What about for updates, right? That's the pain that we're trying to solve here primarily. And so for updates, the typical pattern that you'll follow with EF is that you'll fetch the record that you're trying to make a change to, you'll update it, change whatever property. So in this line, I'm saying update the name to be whatever value they passed me. And then I'm going to call dbcontext.update and save changes. When I call save changes, it's going to dynamically create the update statement based on just the properties that changed. So it's tracking all the properties of author. It knows that name is the one that changed, and it'll produce an update statement that only updates the name and doesn't update all the other properties. It's doing that for me, so I don't have to worry about it. So that's a nice feature. That's one of the reasons why so many people use Entity Framework. A lot of people still use Dapper, and that's fine. It's there's different trade-offs. Here's my report card for using EF Core. I think it has better readability. It has eliminated the magic strings out of our code. It's made it so if I refactor anything in my model, I can run a migration and update the database schema to match, and all my code still works. I don't have any mismatch between my SQL, my schema, and my C# model. They all stay in sync. Security is still good with this. I don't have any risk of SQL injection. I'm not even using SQL directly here. Now you can run SQL queries from EF Core, and these days they are within like a percentage point as fast as Dapper. So they've done a lot of work to make it so that that type of thing is pretty much just as fast as Dapper for that. But if you're just trying to fetch some data and print it on the screen and that's it, and you don't need to track changes, you don't need to do a lot of this other work like generating the query, Dapper will still be faster than EF Core. So performance is taking a hit here. It's only 3 stars now with the EF Core approach. Testability is a little better. The main reason why is because the DB context supports different providers. So you can point it at a SQLite database, you can point it at an in-memory database. And so even though it's still an integration test where you're still talking to Entity Framework, you have some control over what the backend data store is. You can't completely ignore it or mock it out in your code, but you can control it in terms of whether it's in memory or a real database. And so the maintainability is still pretty good here. DB context is still a pretty low level type. You don't want to necessarily couple to it everywhere. There can be problems with that, but it does help with getting rid of some of those magic strings. So it is generally an improvement. And that's why more people are using that these days than writing ADO.NET code directly. All right, so with that, the thing about this part of the presentation here is that I've been talking for a while now, and ostensibly this course, or this presentation rather, is about data access abstractions, and I haven't mentioned any abstractions. Everything we've talked about so far are implementations. They're all just ways to do the logic to get the data. So let's add an abstraction. All right, we're going to add an abstraction. We're going to call it a repository because that's the proper name for an abstraction that you own, that's part of your business code, your model, and it encapsulates your data access implementation details. Note that it's important to remember that for this pattern to be the repository pattern, the important part is the abstraction. The important part is the thing that you own that abstracts away how you get the data. And so a DB context is not an abstraction, it's an implementation. And so if you're using a DB context, but you don't have an interface, you don't have an abstraction, you're not using the repository pattern. Don't let anybody tell you that you are. It's, you're just using, Entity Framework, and that's fine. It's not the repository. All right, so let's talk about the pain points that we have. Well, we'll add this in just a second. We'll talk about the pain in a second. All right, so here's an example of the repository. And to create this thing, I just kind of look at the code that I needed to write. I have an API. I showed you in Swagger what the APIs are for, get by ID, post, put, delete, etc. And so these are the things that support that. So I can get a list of authors. I can get one author. If I just say get an author by itself, or if I just tell Entity Framework to go fetch me an author, just like if I do a select star from author, either way, I'm not going to get their courses with it, right? I'm only going to get the author. And so if I want to get the courses too, I need a way to tell the data access layer, the repository abstraction, that that's what I want. And so I'm going to create another method specifically for that, right? I don't want to always get the courses because that could be a lot of data. And if all I need is to just display the author's name or something, right, then it's silly to fetch all their courses with it every time. It's just a waste. And so it's nice to have these different methods that correspond to these specific different queries. So here, this is an author-specific one that'll let me get all the queries. All right, so when we're working with a repository, the code looks like this. I can say, await, go get me this list of authors, and then in here I can do a projection just like I was doing before, and I can say .toList to get me that list. Now, in this case, this projection right here is not happening at the database level. Entity Framework is not using that to control the query that it's writing. We'll see how we can get that feature added, but in this very naive version of a repository, that's not happening. So this would fetch every row, every column and every row of authors up here on this line. And then this projection here where we map it to the DTO, that would happen in memory. And so if there were 20 properties, I'd have all 20 properties and then I'd just take the 2 I care about. So again, that might not be very efficient. Then this one here lets me get it with courses. And then I can, after I get all the data, then I can map it to a course DTO, myself. So there is a little bit of a separate concern here between the mapping and the data access. I'm showing both just to be consistent, because in the early ADO.NET code, I was directly putting the data from the database right into my DTO. And I couldn't really extract that out and not show that. I mean, that was just part of the logic. And so I'm showing it here again for consistency, although technically the data access code is just this line, right? Or it's just this line here. And then this is a separate step where I'm doing the mapping. And if you're using a tool like AutoMapper or something else, right, then the mapping might just be done for you by that tool, and you wouldn't necessarily have to have all this code to do it. But in the interest of apples to apples, I'm showing it every time. All right, so when you go to implement the repository, this is what your code inside of an implementation might look like. This one's using a DB context, it's using EF core, and the code is really simple, right? So if I want to say go get me one author by ID, then I would just say dbcontext.authors, first or default async, here's the ID. I could also do a .find if I wanted, and sometimes that's more efficient because if it's already in memory, I'll just return the one that's in memory instead of having to make another query. But either way, this will functionally work and get me the author I want. Likewise, I can get the ID with courses. This is the same code that I had a couple slides ago when I was just using EF core directly, using the include, then include type logic. And so it's pretty straightforward to take logic that's in a DB context style or an EF core style that's like inside of your application code and just pull that out and put that into a separate class that is a repository implementation. However, it's not perfect, right? There's still some pain points here. Before we get to the pain points, let's talk about the benefits. So the two big benefits to this approach are that it's very modular. Our data access strategy now lets us kind of plug in different ways of doing data access. I don't have to make a decision to say that I want to use Entity Framework everywhere necessarily, right? I might have some places where I want to use Dapper and other places I want to use EF Core. By using these abstractions and these repository implementations, I can plug in different ways of doing that code wherever I want. Also, there's the decorator design pattern that you may be familiar with. Using a decorator, I can extend the functionality of one of these modules with some cross-cutting concern logic. If I want to add caching, if I want to add logging, if I want to add security or anything like that, I can put that inside of a decorator that wraps around my repository and adds that additional capability to it without having to know whether it's talking to a SQL database or talking to a document database or whatever it might be. Right? It doesn't care. It just wraps it with this other behavior. The other thing we're getting is testability. Right? Because we're using an interface, that means inside my unit test, I can create my own version of that interface and pass it in and have it do whatever I want. So I can create a fake author repository and say that whenever somebody calls list authors, it just returns back Steve Smith, and that's it. Right? Now I can write all my tests and I can verify anywhere they're calling to get data that it's Steve Smith. Makes it really easy to write those unit tests. And of course, I don't have to write my own fake author repository. I can just use a mocking library like MOQ or mock and have it do the same thing, but I don't have to actually write those classes. I can just set up that mock inside my test, which makes it really easy for me to write tests for the rest of my code that is using that data access logic, whereas that used to be hard. All right, so what still hurts? The problem is that as we grow this approach, it still involves a lot of code. It's not as much code as ADO.NET purely with all that SQL connection, SQL command stuff, but we still need to have an interface for every entity, right? So I've only shown you author repository, but if you have 50 or 100 entities, you're gonna have 50 or 100 interfaces like that. Then you have to implement each one of those, right? So in addition to having all those interfaces, you have to have all the implementations that actually do the work. And then you need to have a method for every interface and every implementation of a custom query, right? So in addition to the regular list, get by ID, update, create, delete, you also have to have get the author with their courses, get the author with their address, get the author with this, get the author with that, list me the authors from Ohio, list me the authors, by state. You wouldn't say by Ohio, but you might say by state. And every custom query requires another method. And that gets to be a lot of code on a large code base. So overall, the simple author repository report card kind of looks like this. Readability is still very good. The abstraction is going to be named however you want to name it. So you give it a good name and you use that everywhere. That makes it much more readable. Security is about the same as it was with EF, and so is performance, because underlying we're using EF. Testability is now way better, right? We can actually write unit tests for the first time for any code that's using this, whereas we couldn't before. Maintainability is decent, but like I just said, we end up writing a lot of code using this approach. And so we're gonna move on to something else. So the next thing that you can use is iQueryable. And so iQueryable is a thing that you can return from your abstraction, and it will allow you to evolve your queries into whatever it is they need to be for that point in time. And so the thing about this is that you no longer have to have all these custom query methods. Now, if you turn off the meeting right now, I want you to remember that this iQueryable thing is actually an ANI pattern. And so I'm going to show you why it's not the best thing in the world. But it looks like it would solve all your problems. And when Microsoft first introduced it, they showed a lot of cool demos about why it was great that end up not being great if you try and scale them. All right, so the interface does get a lot simpler, right? You don't have to have custom queries. You just have one method called iQueryable that has a list, and then you can get anything from there. The thing about this, though, is that the query logic now is moving from the repository or from your data access layer and into your application code. So here, this is the code that would call the repository using iQueryable, and it calls .list right here, and that returns iQueryable. But then it chains onto that, this .include, it chains onto it, this .select, and this first or default, and all these things are a part of that query, right? The iQueryable provides you with this expression tree that then gets parsed by Entity Framework and only runs when you first try to enumerate the data. So the benefit of this is that we can write this query logic anywhere, right? You can add query logic in your controller, you can put it in your page, you can put it in your view, you can put it in services, and you probably don't want that, right? Because you're going to end up with all this query logic now scattered throughout your whole application, and you're going to be looking at code in a Razor page or a Razor view or inside of a controller or an endpoint, and you're not necessarily going to know if that code is in fact detached from the database or not. Is it an in-memory set of code or not? Right. Sometimes the only way you can be sure is if you call .toList on it and then work with that corresponding list. In my opinion, it's much better for you to be sure that the data coming back from your data access layer is just data. It is just an array or a list of the data you need. And if you want to customize that query and say, well, I actually only need these rows and this filter and that select, whatever, right? Figure all that out in a way that you can pass it to the data access layer up front, rather than tacking it on to the return and making it really difficult to know what's going on. So like my favorite Guardian of the Galaxy says, with great power comes great responsibility. So make sure you're using your power for good. And there's another Guardian of the Galaxy, it's a different galaxy, Master Yoda, who tells us that once you start down this path of exposing iQueryable, it will dominate your application's destiny. It's not good. So if you've worked in a code base that uses iQueryable everywhere, it can be extremely difficult to know where the actual query logic is, because it's not all in one place. It's scattered everywhere. All right, so iQueryable, the number of stars here is still pretty good, right? The readability is not bad. The security is about the same. Performance is about the same. Testability is still decent, although it can be difficult to write tests that use iQueryable sometimes because you're just trying to get back a list or something in a test typically, and you've got to deal with this expression tree. Maintainability is where it takes a hit because your data access logic is no longer encapsulated in one place. It's now everywhere, which can be a problem. So anybody have any questions? I'm going to take a quick break for a sec. Feel free to come off mute or post in the chat. I've been watching the chat. I haven't seen any questions yet.
Yeah, no questions so far. This is great.
Cool. My brain hurts.
So iQueryable being usable anywhere is the anti-pattern you were mentioning.
That's right. Yeah, it's the problem, right? Like if you look at this code right here, this does not look bad, right? This looks pretty much the same as what we've had before when we had just a DB context, right? Like here's my list, and then we're gonna further, refine the query all here, and with everything in one method, this isn't terrible. But imagine that this call to list is inside a service somewhere, and it returns back an IEnumerable of authors, and then you have another service that is calling that service that says, oh, well, we actually need the courses. And so it returns that thing with this .include, and it returns an IEnumerable of authors. And then that gets, passed into, let's say you're doing MVC and you're actually building the page on the server, right? So now in your view, you do this .select to get the view model that you need, and just pass in the things you need, right? And then at the bottom of that view is where you say, first or default or your list or your for each or whatever, right? Those expressions, this .list, this .include, this .select, are all in different C# classes, and they're being executed one after the other in some call chain. And the query doesn't actually run until the view is being rendered. And at that moment, that's when all these things put together will generate that query. And so if you're looking at any part of that as a developer, it's really hard for you to tell what is actually, the query. What is the query it's going to run, because it's now scattered in a bunch of different places. BJ says, do we still need separate repository class for each entity with the iQueryable? With this approach, yes. We're going to add generics here in a couple steps, and I'll get rid of that. You certainly could have an iRepository of T, and it would have an iQueryable of T here, and just jump to generics, and then you wouldn't need to have a separate one. But for the time being, I haven't added generics yet, which is sort of an arbitrary decision on my part as far as the sequence. But I wanted to show the query pane before we get to the generics solution. Other questions? All right. So I mentioned that it would be better if we knew up front what all the stuff was we needed to pass in. And so the way you would do that is you would just pass in an expression tree to your repository. And so what this looks like is your interface now would have a list method, and it could return back this IEnumerable of author, right? It doesn't have to return back an iQueryable. And it could also return back a list, and that would be fine too. But here we're going to pass in this special type here, this expression of func of author comma bool, which I'm going to call a predicate. Now, you may not be familiar with that type, that double generic expression of func of author comma bool, but that is the type that if you've ever said .where with a link query, that's what .where takes, right? .where takes in this expression of func of t comma bool, and that's how it operates. So if you look at this code, where I'm passing that in, this looks just like a standard where statement, right? I'm saying, give me the author repository list a such that a.name equals Steve Smith. This evaluates to a Boolean, so that's the comma bool, and a is author, right? So it's because it's author comma bool. So a is the input and Boolean is the output of this expression that we have to pass in here. And so that's a pretty nice way to do it, right? And that can be as complicated as we want. We could pass in a whole bunch of complex query logic in there. And we know that what we get back on this side is a disconnected object inside of our application, right? It's not an open connection to the database. It's not an expression tree that we're still building and working with. It's just data. It's disconnected data that's an array, it's a list, it's an instance. And that makes it much, much easier for us to think about our code. Whereas if you're using iQueryable, or if you're using DB context even, which returns iQueryable, it can be really hard for you to know when you're working with in-memory data and when you're building a query. And that's often a source of bugs, especially because Entity Framework will compile with anything that matches this approach, but it will only run for certain things it understands how to translate, right? So a.name double equals Steve Smith, it can build a SQL statement out of that, no problem. But if I said a such that, and then I had a custom method here that took in an author and returned true or false, and it was like, is special author, and it was my own private C# method, it'll compile just fine, because that still has the signature of author comma bool. But when it gets passed into Entity Framework to run, it's going to blow up, and Entity Framework's going to give you an error saying, I don't know how to translate is special author into SQL. Help me out. And so that's not great, because it's a runtime exception. You don't get a compile time failure. You only know it fails if you actually run it. So it's not great. And that happens more often when the query logic is spread all over the place and you don't know that it's actually going to run on a database. When you do it like this, right? Because I'm passing it right into the repository. I know this is going to run as part of the query. And so there's no surprise that it's doing it that way. All right. So the nice thing about this is that we have re-achieved our encapsulation, right? We no longer have data access logic and query logic spread all over the whole application. It's all just inside the data access layer, inside that repository. So what still hurts? We still have too many interfaces and implementations. I gave you a hint that we're going to fix that with generics. And we still have a lot of link logic that might be required in the calling code. We don't have link logic all over the application, but we still have it right here, wherever it is we're calling it. We're doing it all in one place now, but there's still this link query logic, which you could argue is data access logic, right? How you construct your queries is some combination of data access logic and business logic, depending on how you think of it. All right, so what does this do for our report card? Well, the readability, I think, is better now because we don't have the query logic spread out all over the place. We've got better encapsulation. The security, performance, I don't think have changed. Testability hasn't really changed. It's still just as easy to test this. We got testability as soon as we added an abstraction. And the maintainability is still about the same. There's still a lot of stuff we need to make this work. So let's introduce another pattern. Let's talk about specifications. And specifications are a design pattern that is used to encapsulate a query as a class. And so when you use this pattern, you can give your queries names because they're going to have a class name, and then you can reuse them. So you build up this library of reusable queries that have names. And so a reusable library of named, executable query things sounds a whole lot like a bunch of stored procedures. And it gives you a lot of the same benefits as stored procedures in the database, but these are actually in your C# code. They're in your application code. So you get the benefit of having named, reusable, testable queries, just like you have with stored procs, but now they're part of your domain model. They're part of your application. You can unit test them. You can version control them with your code. They're not in a separate thing in a data store. So a specification is just a well-named class, and it will have properties that allow it to perform filtering, includes, which is how Entity Framework does joins, projection, paging, caching, etc. And so an example of how you would write a repository that would use a specification is something that would look like this. Instead of passing in an expression of func of t comma bool, I just pass in an author specification, and then in that author specification, I can have whatever of that stuff I need, a predicate, a way to do a dot select, things of that nature. Right? To create, the update, delete, those don't really change. They're the same as they have been. But what we're changing how we do the queries. All right, so how would we work with this? Well, the implementation inside of the repository now looks like this. You'd say, go get me all the authors as queryable, right? iQueryable is not evil. iQueryable is still a very useful thing to use, but you want to keep it inside of your data access layer. So in this case, inside the repository. It's only when we send it back to the rest of the application that it becomes a problem. So in here, we're going to use that to create our query, and then we can add whatever includes were inside of the specification to that query, and we can use the predicate on that query as well. And so just with, this one's a really simple one. It only has includes and predicates, but just with those, it lets you write code that looks like this, where now I can say, here's the specification I want to use on the first line, get me author by ID, and then go fetch that author and then, do all the work with it. So it's a much simpler way to go. And you have this library now of specifications, and I keep my specifications right with the ND they go with, right? So inside of your code base, when you see, I've got an author entity or an author aggregate, right? In a folder right under that is a specifications folder, and it has every different query that you might need for author, right? So if you need to get author by ID or author by ID with courses or whatever it might be, right? All those things are right there. Every custom query you ever needed for an author is in a library of specifications in your domain model. Makes it much easier to do reuse, and you don't have that link stuff spread all over your controllers or your services or wherever it might be. It's all just right there inside your domain model. All right, so what still hurts now? Well, we got rid of all the link logic in the calling code. We put it all just inside the specifications where we can reuse it and test it, and it's part of our domain model. It's not part of our UI project anymore. And so the thing that's left mainly is that we have so many interfaces and implementations. So we'll fix that in a second. Here with our readability, I think that's improved a little bit. I'm going to give it 4 stars because now we have names for these expressions. If you look at a controller endpoint or something and it just has 7 lines of link code and all these and expressions and get this, where that, include that, you don't really necessarily know what the heck that's doing without really thinking about it and seeing exactly what's there. And then if you need to reuse that, you've got to think about every little piece of it and say, well, do I need all that? Do I just need some of it? What is all that doing? Right? And it doesn't have a name. It's very rare that somebody's going to have a name for that expression tree and then pass the named expression into the where statement, right? It's usually just .where and then start typing. And so by having that name, it really helps the readability and maintainability of the application. Performance and testability haven't really changed. All right, so now finally, let's talk about generics. Let's cut down on how many classes we need. We're going to come and we're going to say, let's add t-result to things. And so we're going to have an interface that's going to have things like singular default, list async, and we'll pass in an I specification of t. We'll pass in a single result specification of t comma t result. This 2 types here allows us to do a projection, right? Where T is the entity that I'm using, like author, and T result is the thing I'm projecting to, like author DTO, right? And so I could have a specification that takes in or operates on authors and returns back author DTOs. So you can use specifications as a way to do mapping, especially if you're trying to support projection and do efficient data queries, but you don't necessarily have to, right? It's a little bit of separation of concerns problem there to do mapping with your data access logic. So sometimes I like it, sometimes I don't. It just depends on how important that efficiency is to me. You create a generic repository interface like this one. There's not a lot to what you're seeing on the screen right now because all the implementation of it is actually in this base type, and that's in my ardalis.specification library, which we'll look at in just a second. And then if you want to implement a specification, here's an example of what one might look like. So this author by ID with courses specification inherits from specification of author, implements I single result specification. So that means we're expecting it to only return one row. We pass in the ID of the author that we're looking for, and then we just have our link stuff in here, right? So this is the exact same link that we would have had on a DB context. Now it's in here. And also we can add other features, right? As soon as we start separating specifications out as their own thing, other features become obvious, like querying, like caching. When you're doing caching, the biggest problem with caching that you have to solve is how to generate a cache key that is specific enough for the query that you're running, right? If you just go get a list of your checking account statement rows, and then you decide to cache that, and you cache it as checking account statement rows, and that's the name of your cache key, then if I go look at my balance, I'll see all my rows. And then if you go look at it a second after I did, you're going to see all my rows too. You know why? Because when you go look for that key, I was the last one that made the query, and that's the key that was used, and it's there for you now too. When you are doing something like that, you have to make sure you include all the parameters on that query. So if I'm looking at my checking account statement, it's probably going to have my account ID somewhere in that query. Well, that account ID has to be on the cache key also, right? And so what this is doing here is it's specifying what the cache key would be for this query, and it knows all the inputs right here, right? So it can make sure to use all the inputs that came into it as part of that key. All right, so then your usage looks like this. If you're saying author ID with courses, same type of idea, and you can add mapping to it if you want. So this is a T comma T result. So author comes in, author DTO with courses comes out, and here's all the mapping now inside. Downside of this is that your mapping logic is now inside your specification. Positive is that all this stuff here is going to get used to build the query, and so we're going to have the most efficient query possible. If you don't want to, if you want to do it with all the mapping, then your code just looks like this, right? So we went from, this is the calling code, where I've got 2 lines up here to do my data access, one to get the specification, one to hit the repository, and then all this code here, this other 12 lines or so is mapping code. If I put the mapping inside the spec, then it's 2 lines, and that's it, right? Your endpoint, your controller has almost nothing in it now for data access or mapping. Right, and so your generic repository report card is looking pretty good, right? The readability is nice. It's real short. It's real tight. It's well named. There's no magic strings. Security and performance are about the same as what we were using with an EF core solution directly. Testability and maintainability are both great. The other thing you can do if you want to add to this, I mentioned using a cached repository as a decorator. Well, you can actually implement a single generic cached repository decorator that decorates all of your applications, checks to see whether or not caching is enabled, which you can do on a specification by specification level, and then your performance is through the roof, right? Now it's kind of cheating because we could have added caching to any of these things and it would have made the performance through the roof. But with all the other approaches, adding caching took a lot more work because you would have had to do it in a bunch of different places. By the time we get to this generic cached repo approach, you only have to write that cache logic in exactly one place, and you get the benefit everywhere. And so that's why I give it 5 stars here for performance at that point. So here's a quick summary of overall what this looks like in terms of the number of stars that we've been seeing for each one. It didn't always get better at every step of the way. Sometimes we went back as we made changes, but in every case, we were making changes based on pain points that were evident with the previous implementation. This generic specification repository is pretty much my go-to now. Do I use it for everything? No, because I prefer to use custom straight like Dapper queries and store procedures for things like ad hoc queries that aren't mapping to my domain layer. If I just need a report, or if I have like ad hoc search as part of the application, I don't need to build all that out with Link. I don't need to build all that out with my domain model, right? Those are read-only scenarios where the thing coming back is a read-only representation that just needs to get put on the screen for the user to interact with. And so I'll use the simplest pattern for that I can, which is usually Dapper and a store procedure for that. But for the main part of the application where I'm doing CRUD operations, I really like the combination of the specification and the repository, and sometimes the cached repository if I need the performance. So that's the main thing here. We have different patterns, different trade-offs. We've started out with low-level code. We've encapsulated that. We had complex query logic. You want to make sure that's encapsulated too. You want to make sure your calling code can be as simple and readable as possible. Use the right patterns for the right situation, the right context. You can combine patterns together like specification and repository. I didn't mention enough, but a lot of this you get for free from the Ardalis specification library, which is also used in the eShop on Web sample, and it's also used in my clean architecture solution template. So you can check those out. And so yeah, if you like this, let me know. You can mention me on Twitter. Contact me at NimblePros, grab the stuff from .NET Data Access Tour, and enjoy the rest of Stir Trek, even though Stir Trek was last week. Let me get this demo working real quick so I can show you some stuff with the time that we have left. And otherwise, let me know what questions you have. Anybody?
I forgot from earlier. Does the specification class, does it inherit from? Is there an interface, like a specification interface that it inherits from?
In my
On
case,
average.
in my case,
Okay.
yes, just because it's easier. So in Ardalis specification, this is a NuGet package. It has adapters for EF6 and EF core, but the main specification is in here, and it looks like it's got this I specification that has all the things it needs to support, and then there is a base specification here that's specification of T and specification of T. So you get all this here. So when you're using it, if you want to see a real example. Let's get another tab here. If we go to eShop on Web, this thing uses specifications also. You can go into the application core. It has everything in the specifications folder. Like I said, I would normally organize this with each entity these days, but here's what they look like. So, it's just a query with, where this and include that, type of thing. And it inherits from specification of basket in this case. If you want a paginated one, this one supports paging. So here's my query, and I can say where, whatever, skip whatever value, take whatever value, and those are the things coming in through the constructor. The skip, the take, the brand, the type, all the parameters for the query are in the constructor. Does that help?
Yeah.
All right. I have to run a migration or something here. Oh yeah, I could run seek too. Let's see. Here's that. When I gave this talk at Star Trek, it was on my laptop, and I'm presenting on my desktop, so that's why I didn't run this beforehand, because I'm a bad presenter. This is my first time ever presenting. I didn't test my demos ahead of time because I was too busy trying to eat dinner. Oh, right, because it's running. Okay, that's why I can't do it. Go over here. And what are you running in? IIS. Stop. Kill IIS. Yes. All right, IIS, stop locking things. All right, that's better. All right, so there, now I created all the things. Now I can just run it. I'll just run it from here. And it's port 5001. Here we go. We can open Swagger. We can go look at all the authors, try it out, execute. Hey, it worked. Look, so here's the authors. Notice that the authors don't have their courses with them, right? Because this is just saying select star from authors. If I want to get them with their courses, then the convention I usually use when I'm building APIs is that list methods or endpoints don't include a lot of related data, but when you say, give me this specific resource, to use the REST terminology, then I'm going to give you all the related data with it typically. So when I say, give me author ID 1, now it's going to include all the courses in addition to the author information. And so that's doing the join. Right, so this is kind of what the data looks like that we've been looking at this whole time. And inside of here, you can see the queries that were executed. Right, so here's the query that ran, select star from authors, or select all that. And so you can easily see all that. The other thing that is in the README file here that I was just looking at is if you want, you can run what's called seek. Let me just put that in another window and run that. Seek is SEQ, and I don't have Docker running, so that'll be a problem. Docker desktop. How many of you have used Seek? Anybody? It's just a really nice localhost logging solution. I use it a lot when I'm doing training workshops because I can give it to the students and then it gives me an easy way to see what's happening on their code without having to just scroll through the console window. All right, so now we've got that running, so then this ought to work. There it goes. And I'm doing, I think, right here, 5342. So here's seek, and I would like it to be dark, I think. Dark. There we go. And maybe now that it's running, if we go back here and run this again, execute, then that might run here. Loading complete. It's not really demoing very well, is it? All right, what did I do wrong? I think it's supposed to be talking to that. Let's go here. Let's go look at program CS. I'll have to restart it, maybe, because that wasn't there when it started. All right, let's try that. So go back here and stop it, and run it, and see if that does anything. There we go. All right, so now it's talking to it. So this is all the console output. Looks like it actually was working before a second ago too, because you can see where it's shutting down. I just had to get the filters out of the way. But now if I run query here, let's try to run that query one more time. Then in seek, if we run this again, there it is. There's our query that we just ran at 39 after, which is right now. So this just gives you an easy way to see all the log output, and it persists. So it's not just going to go away as soon as I close the console window or whatever. And I can filter it, and it's also structured data. So I can see, all the SQL is right here in the SQL variable that I can extract out, and along with other metadata and stuff here. So it's a really nice tool if you haven't used it. It's free to just use in Docker like this. If you want to use it in production, then you have to actually buy a license and host it somewhere. They don't have a SaaS model that I know of yet, but you can put it in your own virtual machine or whatever, and it's nice. So with Seek running, we could come back in here. We could go see, well, what does this look like with a repository with specifications? Go get me this author, say, to execute. And so we get Julie Lerman with her data. And in Seek, if I run this again, it'll show me here's the query it ran. Right, so this is the command that actually was executed. It was generated based on my specification. Entity Framework created that for me, and here's all the data that it has. So that's what I got. Any other questions, comments, things you want to see? Anybody want to start using specifications now?
Oh, definitely. Definitely want to play with those now. I was not aware that was a thing.
Yeah, so the actual code, again, it's all in here. It's broken down by all these different options that we did. And so if you want to play with this yourself and do any comparisons or anything, it's, feel free to grab the repo. The specification one is here. I didn't show you the caching, but here's what a cached repository of T would look like. For ads and things, it wouldn't really do any work. But when it does a first or default or a list, it would use the cache. So it would say, well, if the specification has caching enabled, then use its key, and then you call cache.getterCreate to get the thing and do that. And again, the thing about this is that you only have to implement this once. This is the only place in the whole app that I would have to have this logic, and I would be able to use it for every entity, no matter how big my application was. So that's the kind of scalability that I really like that these designs give me. Not the scalability like you typically think of I can always add more nodes to my server farm, but the scalability of your logic in your code, where the caching logic is only in one place. The implementation of how I use Entity Framework is only in one place. And in this case, you don't even see the code because it's all inside of the RDAL specification package. So the EF implementation is coming from this repository base that I get for free. But I do have my own iRepository that I control, and it's getting most of its functionality from this other thing also. But I can tweak it and add or remove. Well, not really remove, but I can tweak it however I want here. And then this is how you interact with it, right? So if I want to say get an author, it's here's the spec, here's the list method. If I want to get author by ID, same idea. Here's the spec, here's the call to get it. If I do the mapping myself, it takes this code here to do the mapping. If I do the mapping inside, then it looks like this. And I would say, notice the spec has a different name, as DTOs is in the name. So it gives you back the DTO. This presentation makes me feel omniscient, says Rich. Nice. All right, so I'll actually be done now with showing you cool things, unless anybody has any questions.
I don't have questions about the stuff you're showing off right now, but you mentioned Julie Lerman. Are there any other authors on Pluralsight you'd recommend?
Oh yeah, tons. There's so many good folks on Pluralsight. I know more topics than individuals. It depends what you're trying to learn. Depending on what you're trying to learn, there's different folks that I would recommend. So, let me know what your topic might be, or feel free to shoot me an email or something. My email is at the start of this, was just steve@nimblepros.com. And I can point you at some good authors. Deborah Carrata is great for Angular. Julie Lerman's great for anything Entity Framework or domain-driven design. A lot of folks are good for ASP.NET or C#.
I was thinking more general C#, but I'll probably just hit you independent, not take up much time here.
Cool. Yeah, feel free to fill out the feedback form that Stephen just posted, and I'll hand it back to Stephen.
Great, thank you, Steve. Fantastic presentation. So I did drop the link for that feedback form there. As a reminder, that is completely anonymous. So good, bad, indifferent feedback, please tell us. We want to know how we're doing. I will leave that survey open for 24 hours, and at which point I will aggregate all the results and I'll get that over to you, Steve.
Cool, thanks.
All right, well, if there's nothing else, thank you very much, everybody, for attending WOGNet tonight, and have a great rest of your day.
Thanks, everybody. See you later.